Okay, good morning again, Professor David J. De Los Reyes. Okay, it's August 7. The time is 3:27 a.m. Okay, my next long video format discussion for this morning will be college algebra. Okay, we are running smooth on college algebra. Okay, this will now be lesson number 25. Okay. I will give you one more example on the simplification of a complex rational expression or just simply fraction. Okay, let's proceed. This is more complicated than the previous example. Simplify the rational expression. The given rational expression is it's really complicated because a complex rational expression is that the numerator also contains several fractions, and the denominator contains again several fractions, so it is complex. Okay, I will try to read the complex rational expression. 1 over a square plus 7a plus 12 plus 1 over a square plus a minus 6 all over, okay, 1 over a square plus 2a minus 8 plus 1 over a square plus 5a plus 4. So the numerator contains two fractions, okay, and again the denominator contains two fractions. So this is to be considered a complex rational expression, or in layman's language, fraction. Okay, let's try to bring out the solution. If we try to bring out the solution, I did this myself, even the textbook doesn't do like this, okay, but this is my own. Okay, we'll try to simplify this one. We'll try to factor out the given quadratic equations, because if you try to notice it, all the denominators are actually quadratic equation, right? They're all quadratic, so we try to factor out these quadratic equations. A square plus 7a plus 12, we are done with factoring, right? The possible factors of a square will be an a and a, and the possible factors of 12 is actually 3 and 4. This is plus. So it's a must that the sign of 4 and 3 will be the same for it to be a plus 12, right? Let's try to check the middle term. A 4a plus 3a will be 7a. It's correct. Alright? Next one. A square plus a minus 6. Possible factors of a will be an a and a. And the possible factors of 6 will be a 3 and 2. But if we try to see the sign of the pure constant term, it's negative 6. So it's either this is plus 3 and this minus 2, or this is plus 2 or minus 3. But let's try to place this one, the 3 to be plus and the 2 to be minus. Let's try to check the middle term. 3a minus 2a, it will be plus a. It's correct. So these 3 here should be plus and these 2 here should be minus. Next one. A square plus 2a minus 8. Right? Possible factors of a will be a and a. And the possible factors of 8 will be 4 and 2. The sign of 8 is actually negative. So let's try to do this 4 to be plus and this 2 here to be minus. Let's try to check the middle term. A 4a minus 2a will be 2a. So it's correct. Okay, last one. A square plus 5a plus 4. The possible factors of a square will be a and a. And the possible prime factors of 4 will be 4 and 1 or 2 and 2. But we try 4 and 1. Okay. the sign of this 4 here is plus, so both 1 and 4 should be plus. Let's try to check the value of the middle term. A 4a plus a should be 5a. So the middle term is correct if this 4 here is plus and this 1 here is plus. So after the factorization of the given quadratic equations on the denominator, I will let n now to be equal to the numerator, the top portion. I will let that capital to be equal to capital letter N, the value of the total numerator, that is 1 over a squared plus 7a plus 12 plus 1 over a squared plus a minus 6. Okay? We got already the factored form of this, so I will rewrite this one in factored form. That is 1 over a plus 4 times quantity h plus 3 is 1. Right? The second one is a squared plus a minus 6 is actually the product of a minus a plus 3 times the quantity a minus 2. Okay? Simplification or simplifying. There is a common factor, a plus 3, we bring it out, right? So this is 1 over a plus 3. Open bracket, what remains for the first one will just be simply a plus 4, we bring out this one. Second one, we bring out a plus 3, so what remains inside will be 1 over a minus 2, close bracket. So this is 1 over quantity a plus 3. Okay, we do it like this. It seems we are on the short videos. The product of 1 times a minus 2 will be a minus 2. And the product of 1 times a plus 4 will be a plus 4. And the resulting denominator will be the product of a plus 4 times the quantity a minus 2. This has been coming out in the short videos and we are saturated with this one. So we should know this one, okay? So simplifying, this should be 1 over a plus 3. A plus a will be 2a, minus 2 plus 4 will be plus 2. The denominator will be the product of a plus 3 times quantity a plus 4 times a minus 2. That's it. That is, okay, well, we try to bring out 2 here. So this is 2 common factor times the quantity a plus 1 all over the resulting denominator will be the product of the 3 binomials a plus 3, a plus 4, and a minus 2. So this is the simplified equivalent of the total numerator, okay, in factor form. Okay, it's not complicated to say. You can see that they are already placed in the so-called factor form. We will let the denominator also to be this part here plus this. The denominator is actually 1 over a squared plus 2a minus 8 plus 1 over a squared plus 5a plus 4. We got already the factored form equivalent of this one. Okay? A squared plus 2a minus 8 is actually the product of a plus 4 times the quantity a minus 2 plus the equivalent of this is actually the product of a plus 4 times a plus 1. This is. Right? So after the substitution, there is a common factor a plus 4 here. We bring it out. So this is 1 over a plus 4 times open bracket. What remains on the first one will just be simply 1 over a minus 2. We bring out a plus 4, right? Second one, we bring out a plus 4. What remains inside the bracket will be 1 over a plus 1. And again, like what we are doing in the shorts videos in which we are saturated, okay? 1 times the quantity a plus 1 will be a plus 1. And 1 times the quantity a minus 2, okay, is actually a minus 2. I forgot the quantity here. Right? And the resulting denominator will be the product of the two binomial a minus 2 times the quantity a plus 1. So this is a plus 1 times a minus 2. Simplifying the numerator, a plus a will be 2a, and 1 minus 2 will be minus 1. This is multiplied by 1. Or if we try to multiply, okay, the simplified equivalent of the denominator will be 2a minus 1 all over the product of three binomials which are a plus 4, a plus 1 times a minus 2. Okay? Let's go back to the problem. We represent this one to be n, and we represent this one to be d, and they should be divided, right? So this is a numerator over denominator. So instead of writing this whole thing here, which is complicated, I will just write n over d, which is actually equivalent to this, right? So they should now be equal to. I will write the numerator. Where's the numerator? It is this. 2 times the quantity a plus 1 over the product of these three binomials here, divided by the value of d. Okay, but instead of dividing, so I could minimize my writing. Okay, we lock the blackboard already. I will now change the operation from division to multiplication. So I will raise this one up, then I will put this one down, then I will perform the operation multiplication. Right? We are lacking space. Okay? So they should be the product of the three binomials a plus 4, a plus 1 times a minus 2. It is this. This goes down over 2a minus 1. Okay? This is now the importance of the so-called factoring, because after the so-called factorization, we could cancel things, right? The operation on the numerator are all multiplication, and the operation on the denominator are all multiplication. So we are free to cancel common terms, right? A plus 4 cancel with this, right? A minus 2 cancel with this. The operation is multiplication, so we are free to cancel, right? So what remains on the numerator will be 2. This is a plus 1, so this will be a plus 1 quantity square. What remains on the denominator will be the binomial a plus 3 and the binomial 2a minus 1. So this is 2a minus 1. Okay? So this will be 2. We expand this one. We pass by the expansion of a binomial. It will be the square of the first one. The product, the middle term will be a times 1 times 2. That will be 2a. And the last part will be the square of 1, which is 1. Okay, that's the square of a binomial. All over. For this one, we will use the distributive law because they are both binomial, right? So we will take a times the second binomial plus 3 times the second binomial. Okay? The numerator will be 2a squared plus 4a. Sorry, plus this one. This is plus 2. 2 times 1 will be 2, right? That's the syntax error. Right? 2a squared, 4a, so this should be plus 2. Okay? The denominator will be a times 2a will be 2a squared, a times minus 1 will be minus a. This is 6a. 3 times minus 1 will be minus 3. So this should be 2. Sorry for that one. Okay? And if we try to simplify the denominator, the square term got no other component, right? So it will be 2a squared minus a plus 6a will be 5a. This is minus 3. So the simplification of the given rational expression, which is complex, right, is 2a squared plus 4a plus 2 over 2a squared plus 5a minus 3. And this will be our final answer. Okay? That's the way how to simplify a complex rational expression. Okay? If you know factoring, it will help you. Right? So the first part of the solution, we factor out. Then we try to substitute. We simplify. Again, we substitute. We simplify. We take the ratio. Again, we simplify. So this will be our final answer. Okay, that's it, guys. So for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. Okay. Try to watch my long video format discussion on college algebra. I will assure you, you will learn something from it. Okay. Good morning from Los Angeles, Professor David J.